Recently I wanted to set up the web service Anubis, which weighs the soul of incoming HTTP requests to stop AI crawlers. So it's a software that sits in front of your website or in front of your web service and protects it from AI crawlers. And it's become a quite popular project in the last few months. So it has 14,000 stars on GitHub. And I mean, it's all fine and good. It's a great software. If you've even seen it a couple of times in front of some Git repository. So, and if we go to the website, I hope it will also show the software in action. Yeah. So here it is, making sure you're not a bot, and only if the software is able to ensure we are not a bot, we are forwarded to the website, or the website is forwarded to us, rather. And yeah, so this is great for anything where you want to protect content from crawlers. So, yeah, I mean, it's super straightforward, but as you may have also seen, the styling of this service is not quite, well, I mean, all this stuff is personal and all that, but also the mascot, I mean, it's not really my taste, to be honest. The problem is they don't really, so this project doesn't provide a straightforward way to change the styling. I even think there was an issue about that, about changing the default style, so changing the pictures and the CSS and all that stuff, the wording and stuff like that, and there is no option. They even have like so you can pay them to have like custom styling, which is kind of, yeah, I mean, I guess it's the attempt at a business model, but it doesn't really work. I mean, this is a free open source software project. I mean, it's MIT licensed. I mean, you can just download it and build it yourself. And I thought about doing that, but it's a Go project. I mean, which is great. I mean, it's a single binary. That's always like nice to see. I really like that. But then I would have to install all the dependencies for building it. I don't know. Yeah, no, it's not on here, but it's in the documentation. So if we go here, oh yeah, here, unbranded version. Yeah, that's right. Commercial support and an unbranded version. So you can pay to have like custom CSS and fonts and images and whatnot. And again, oh yeah, $50 per month. And again, there was an issue where someone was saying, well, they if I can speak, they were running the software in front of their service, and the first like comment they got was if their website has been like defaced, so basically hacked by someone else, which is not the reaction you typically want to have. So again, I thought about doing that. But there are quite a few dependencies. Like you have to have Go, and then also like some ESLint for the JavaScript and whatnot. So I decided to not compile it from source, but I still wanted to run the software without like the like anime style images and styling. So I decided to just kind of hack it together, and I've also published the code. So if you go to my Git, let me make this a bit bigger, and then to restyle Anubis, I have compiled a few scripts to restyle the Anubis software. And I have to say, I still have not gotten around to setting the service up, so I don't know if I have successfully restyled all of it. But I have just tried to restyle the default page, so the default error page that you see when you don't set up the configuration properly. But I'll show you in a second. And in this video, I kind of want to go through it. I kind of want to show you my working process, how these scripts work, because I found it quite interesting. Alright, so what I will do is I will simply copy, or I will simply git clone this. So let's just make a new directory, vid for video. Then we go here and we type git clone, and then my repository. And if we go here, we will see a bunch of scripts and two directories. So the main script you want to run is run.sh. This will download the latest version of Anubis and patch it. And this is not, I should have said this in the beginning, maybe I'll have it in the title. This is not like patching like suckless software, where you have like text patches and you just patch them. This is like a binary patching, which is, I found it quite fun. So But again, so let's just go through this. So I have two directories here. First up, I have the original image files, and if I open these up, these are 3 images for the different like states. So this is great, you're not a bot. This is, well, I'm not sure, and this is okay, you're a bot. You can enter. And I have kind of chosen my own images, which are more up my taste, maybe. So this is for the okay, I'm not sure. This is for okay, great, you're not a bot, and this is for okay, you are a bot. So these are kind of more my taste. All right. But again, as I have said, the Anubis software is like written in Go. So you get one binary you can run. So it's not as simple as swapping the old files for the new files in like some configuration directory, but these files are embedded in the binary. But let's just, so I have the script get latest release, which gets the latest release. So I have some GitHub API magic, which I got from some Git digest. Then, yeah, I mean, then it just doubly gets the tar archive, unpacks it, and copies the Anubis binary to a new binary called anubis.patched. So if I run this, it will do a bunch of stuff and we get a bunch of output because I didn't specify quiet flag for wget, and it unpacks it, and now we have the actual tar.gzip, but also the untarred Anubis directory. So if we go to that, we see a bunch of stuff. So readme, a doc, a run, a bin, and in the bin, of course, there are the binaries. So I don't know what this is for, but this is the main binary that I patch with these scripts. All right. So, but now we have this anubis.patch, and this is just a copy of this file, obviously. And if we run this, we get a bunch of output, and we get a, whoops, not a new window, but not tab. We get a new service at host 8923, I think it is. Great. All right. So we get an error file about misconfiguration, blah blah. But here we see the default style. So here's one of the images from the directory I've just showed you. So this something is wrong image. We see the default style, so the default colors, and also this footer, or this footer. Footer? And I will hide this. I will change the colors and also the images and also this oh no's, because I find that kind of, I don't know. I mean, yeah. Okay, whatever. So let's just quit that. So again, the first script I run is patch images, and this is also the most technically advanced scripts. The other scripts are just a bit of shell scripting. So let me make this a bit larger. So let's go through this. So these are just some variable definitions. So we define a variable file to patch, which is anubis.patch. We define like the old images, the new images, and then we create a hex dump for this file to patch. So for our Anubis binary, because why do we need a hex dump? Well, I mean, you can, and this is all just me hacking this together. Like there's probably a very like a more elegant way to do this, but I just did it with a hex dump and grep. So, and the script is not the fastest, but it works. So works GM. So we create a hex dump to be able to, and I mean, I can, yeah, let's just go through this like one by one, because I find the working of this the most interesting. So let's create this hex dump. This will take a while. I may just cut forward. All right, it's done. So if we open that up, we see, and this is a very large file, as you can see. So over, what is that, 2 million lines. We see all the bytes in this binary. So, and on the left, we see the memory address. And then there are the actual like bytes. So it's a hex dump. If you've never seen that, that's what it is. So the first byte is this one right here, or at a, it's 45, and then 7F, and so on and so forth. So these are just like the ones and zeros written out in a more readable form. I mean, for like 4, you could have also written what is it, 0, 0, 1, 0, 0. No, is that right? No, sorry. It's like 0, 1, 0, 0. But that's not really readable. So yeah. All right. So all the data is here. Let's just say. Okay. Next up, okay, so now we define a function, and this function will run 3 times for like the happy version of the image, the pensive, or I call it halt version of the image, and the reject version of the image. So for the 3 images. And in this function, we again create a hex dump, but this time for the old image file, so for the original image file. And then we get the start address of this image file in our binary, so in this hex dump we just created, and we get the end address as well. And then we, okay, so this is just echoing, and then are you sure? So this kind of stuff. And then we call dd, and literally, well, literally, I mean, what else? We patch the file. It's pretty simple. So we write our new file at the where is it? At the start address we got up here, and we write from start to end, and in our file to patch, and we use the new image. But again, let's just go through it with like an actual example. And this might be a bit of a long video, but I find this super interesting. Well, not super interesting, but I mean it's pretty straightforward once you kind of get the hang of it. But still. So let's just do this and do this. So now we create a hex dump for the image, which is super fast because the image is not that large. And if we open that up, we get all the bytes of the image. So it starts with this right here and goes down all the way to this. So what we now want to do is we want to find where this sequence of bytes starts in our big binary, so in our anubis binary, and we want to find the place where these bytes are located in that as well. And we can, again, if we look in here, we can do this with this line and this line. So to get this, let's just only call this grep command. There's one, no, there's no missing. This one is too much. Or no, rather, let's just let's call this one first, so you see what this does. If you don't know off the top of your head. So whoops, this would be good as well. So original happy. So we specify the hex flag, and we just get the first line. And if we just get the first line, we get like this address thing as well. And we don't care about that because this is not in our binary in which we want to grab. I hope that makes sense. So we call cut F, capital F for, okay, operate on white space, not on tabs, and 2 for, okay, I want the, and the dash at the end, okay, everything from column 2. And I think cut starts at index 1, so yeah, so this is it. So only discard the first column is what this says. All right, and then we simply use grep to grab that. So we have now this as the output of this subshell we run here, and then we simply grab it. Let me think. File to patch. Yeah. Okay. So all right. So no, this subshell we just ran, which gave us this output, and now we can replace the subshell for like demonstration purposes, I guess. And we want to get anubis.patch.hex. And if we run that, oh, and we want to get F0. And this is again the same as this command right here, but now we only want to get the first column. And maybe I should have written 1 here for clarity's sake, but 0 works as well. So if you run that, this will take quite a bit, because it has to go through the entire file. But it has finished now. And it didn't cut, by the way. And it has given us the address where this image starts in the binary. So if we look at the hex dump again, so .hex, and search for this address, it will take a while, but it will give us the location at line 1,344,070. And here we see the sequence of bytes we just grabbed for, obviously. I mean, yeah, how else? And the same works with the end bytes. So for this I call what do I call? I think tail. So we want to get the last 2 tail lines, because the last line is always empty for a hex dump. And so the second to last line is the one has the sequence of bytes we actually care about. So, and then we pipe that into head to get like the first line of this output, and then we can type it into F2 to get like, not this, to get like the actual thing we want to grab for. And if we now grab for this, I mean, it will again give us a line number, or a memory address rather, not a line number. And this will be, this will be obviously greater than this, and the difference will be the size of the file, obviously. So if we look at happy.text, hex, not hex, but do like, what is it, this? So this file is 32 kilobytes large, and if we look at the difference between this address and this address, it's about 32 kilobytes. Yeah. So again, so this is pretty straightforward. So we now have the kind of where to start and where to end. And if we now go into this script again, down here we subtract the end or the start from the end to get the amounts of bytes we want to write. And we seek, this is back here, we seek to the start address so we want to start writing at this address, and we want to write these amounts of bytes. Yeah, so I think this is, I hope this is all pretty, like, this is all understandable. All right, and again, this is the file we want to write, and this is the file we want to write to. So yeah, so this is pretty much it. And again, I got these options from like some Stack Overflow post. I will link it on my website when I publish this video on the video section. All right, so this was kind of a bit of stuff, but I want to go through the other scripts as well, and these are super simple in comparison. So I think the most important one is the colors. I mean, there are really only two left. So patch CSS and patch colors, and these are kind of the same. So patch CSS calls patch colors. So for the color script, or get colors rather, it's pretty straightforward. It doesn't look straightforward, but it is. So I have this colors file, which I have also in the Git repository, and in here I've copied the CSS from Anubis, which defines the colors. So if we go back here and go to inspect, it will take a while, and go into sources, and I think in here, yeah, so here's the style sheet, and I've literally just selected this and copied it into the file. So pretty simple. And then I have back here, I have written my new colors, which I want to have after these double slashes. And I mean, this is kind of, you don't need these slashes. I've just written it like that because I find it the most intuitive. And I mean, you can do it any other way, but I found it the most intuitive, as I said. All right, and this get colors will now, let me just run this and you'll see what it does. So again, so this is the file. And if I run this, it will generate, so it will replace every line where there's a hex number, so, or a hex color. So a string that starts with hash and then has 6 symbols afterwards. It will replace this line with, up here we can see it. So, yeah, so it will replace that string with the second string, which also starts with a hex, with a hash, I mean. And then it will just generate this kind of set syntax. So yeah. And then we just pipe it into grep to remove all these other lines. Then we pop it into sort. So grep hash, I think. Yeah. So we don't care about like these lines right here. Then we pipe it into sort to sort this, because some of these colors are duplicates. So for example, let me see which one can I find. I think this one, yeah, this one and this one right here. So we want to sort these first, and then we want to remove any duplicates. And I think sort can also do this, but I haven't bothered. So it's just called unique, and then we get all the unique replacement pairs. So yeah, that's that script. Oh yeah, and then we then we kind of remove the new lines and replace them with spaces, so like this. So we have just one line. All right, and then we call this script from our from this patch css.sh. So first up, we want to patch two other things. We want to patch this oh no's, which I will patch with a no, and notice these spaces here. These spaces are because you need to patch the exact amounts of bytes. So you need to replace this string with a string that's exactly the same length. Otherwise, the whole binary will not work. You will get a segmentation fault because the memory addresses don't fit anymore, because it's statically linked. I mean, even if it wasn't, but still. And I also want to replace this footer CSS. I want to hide the footer, so I just replace this text align center rule with display none. And this as well I got from the CSS. It's I think down here. Where is it? Ah, yeah, here. So footer text align center. And I looked up how, because right here you have these new lines and this white space, but this is not present in the binary, and you just have to kind of look through the binary. I mean, oh yeah, this I should have also mentioned. If you do a hex dump with the C flag, you will get the text. That's because if you look at kind of these binaries, so some of these encode text. So some of these bytes will be displayed as text, or are gonna be text. And with C, I mean, I can do this. I mean, this video is long enough anyways. So let's just go through it. So hex dump C, anubis patched. And we want to pipe that into anubis patched hex C. Let's just call it. Okay, I'll cut forward when this is done. All right, it's done. So let's take a look at it. So again, we see all the memory addresses on the right we see if these bytes encode any text. So, and it's quite nice because now you can like search in the actual hex dump. You can search for text, and I mean it doesn't, of course, always work because there are these the text is not like, if you search for some text and it's kind of split over two lines, it won't find it obviously, but it's good enough. So let's just search for oh no's, because if we go here, this text obviously is somewhere within this binary because it's here on this page. We see, okay, we have found kind of the place where this is specified. So there's this oh no's variable, I guess, and it's set to oh no's. And if you search for that, actually, oh no's, you will find more definitions, which are, I think, for other languages. So here, oh no, which is, I guess, French. Yeah. So, oh nein, here's the German one. Benchmark wird durchgeführt. Ah, yeah. Du bist kein Bot. Ah, that's nice. Okay, so, and we could replace all this other text as well. But, yeah. So, back to the script. I want to replace this with no, and the footer CSS with, oh yeah, and, I forgot. Yeah, so, I wanted to show the, but it's the same thing. Just open the hex dump and look for footer. And, yeah, there are multiple footers, of course. So here it is. So, yeah, footer, and then dot. Yeah, I don't remember that. Oh no, here it is. Here, this is the CSS I replaced. Footer, text align center. I think the other one was for like I don't know, something else. All right, so I replaced this with the display none CSS. And again, here this white space because you need to patch the exact bytes. So you couldn't, for example, insert more CSS or CSS that's longer than this in this example. And the same, I should have said this, I guess. The same goes for the images. You can't patch in images that are larger than the images that are inside. So if we look at the images, these are all, okay, ignore the hex dump. These are all like 32 kilobytes. But if we look at the new, these are all below that. So, yeah, it's fine in this case. But you need to kind of keep that in mind, because otherwise, again, and I should have also said that DD will, if the file you're patching in is smaller than the one, and this is, where is it, patch images? This is why right here we specify from like how many bytes we want to patch, because otherwise it will just patch the amount of bytes in the new file, and this will of course not align with, so this will not be the same amount of bytes as the old file. So we specify how many bytes we want to patch, and the other bytes which are not present in this new file will just be filled up with zeros, which is fine in this case. So yeah, I hope that made sense. I should have said that earlier. I think that's important. Okay, whatever. If you're interested, you're still watching, I guess. Again, patch CSS. So we want to replace that with this and that with this, and then we want to run the get color script and insert all the rules which it outputs right here. So we get this long set command, and then we want to replace the file in place, and we want to replace it in this anubis.patch file. All right. So yeah, that's it, pretty much. Yeah. So and this run file just calls all these scripts, and we can run through this now from start to finish. So again, yeah. So let's just run through it. Oh, and if you've already downloaded the tar.gzip, it will not download it again, but it will unpack it again. I don't know. I just didn't bother fixing that or bothered improving that. And this will take quite a while. I mean, you saw how long it took for all these individual steps, and now it does them all in a row. So it will take a while, but in the end, you will get a Anubis binary with a better, or with customized styling, let's just say. Yeah, so it outputs like, okay, from here to here, are you sure you want to patch in this file? Yeah, sure. And I mean, this is kind of unpractical for like actually customizing it like to your exact liking, like having your own custom CSS and whatnot. But it's like, it's good enough for my purposes, or at least I think it is. Maybe I will change my mind on that, but when I actually use it. But I think it's good enough because I mean, this page is only shown for a split second anyways, in most cases, for like most normal visitors. So I think it's fine. And I mean, the images I selected are not very serious as well, but they kind of fit more my taste, I guess. And yeah, so my only point was that I didn't want to have these kind of weird images, or these images which don't really fit my taste. I don't want to have these displayed the first thing someone sees when they visit my website. I would find that kind of weird. All right, yeah. So now it's patching the CSS, so it's almost done. All right, it's done. So if we ls, we don't see any difference, of course. But if we run this Anubis patched file now, we will see, and let's just duplicate this page so you can see the difference, and hard reload that by Control-Shift-R, we see the new style. So we see the image we patched in, we see the node we patched in, and we see the new CSS. Yeah, so this is not really good styling. Yellow on white doesn't really go that well. But in dark mode it looks nice. I might change that. But yeah, so it worked perfectly fine. So again, I haven't tested this on like actual pages, so this is just some error page, but I think it should work on the other pages as well, because the other pages use the same CSS, they use the same images, and yeah, so it should hopefully work. Oh, I guess we could look at the images. So if we go to pensive, yeah, so we get this, and if we go to happy, we get this one. So yeah. And oh, by the way, I made all these 512 by 512 pixels because that's what the original images are in as well. That's why you have this weird white space down here. Or not white space, but empty space. All right, so I think that's pretty much it. Again, you can check this out by visiting my Git and cloning this repository. Oh, I should have mentioned. Oh, I forgot to make to add a license here. So this is GPL v3 as always for me. So feel free to like check it out, redistribute it, change it however you like, and redistribute your changed versions. And if you have any if you have anything, just write me an email. All right, so I think that's it. So I find this way nicer than this, to be honest. Yeah. Okay, I think this video is long enough. That's it. Have a nice day.